Hello, everyone. Welcome to A22 Day 1. We're going to be talking about more operations with complex numbers today, among other things, such as learning how to write an equation. Like if we knew the complex roots, we want to be able to write the equation in standard form for a polynomial that has complex roots. So our goals are pretty simple today. We want to learn how to multiply and add complex numbers, and we're going to be talking about complex numbers that are like multi-part, so like binomial type complex numbers. And I'm going to show you some of the nuances and whatnot associated with those two operations. Then we want to understand what conjugate pairs are. So this is a brand new word we haven't seen before. So we'll talk about those, make sure you understand what a conjugate pair is, and look at their properties. All right. And then our third goal here is to write the standard form of a polynomial who has complex roots. Right. So like I said, we might run into a polynomial, we know the roots, and then we want to write its equation based on that information. All right, so we're going to learn all that today. So let's go ahead and get started here. We're just going to talk about some of the ins and outs here, adding and subtracting complex numbers. Some of the things that you want to remember here when you add and subtract complex numbers is you want to make sure that you combine all like terms. Okay. So make sure you like terms should be combined. And then the other thing you want to make sure you do is distribute the negative. And we'll see what this means here in just a minute. Okay, I only bring this up because students forget to do this all the time, especially in this scenario. So I'm mentioning it so you'll write it down and kind of think about distributing that negative. But let's say real quick we have two complex numbers. Let's say our first complex number is 2 plus I, and we have another complex number we're going to subtract here. We're going to subtract from it another complex number. So let's say it's 3, 3 plus 2I. Something like that. Okay, and we want to add those together. So if I were doing that over here, we would say, okay, so 2 plus I, and then minus 3 plus 2I. And you might think, well, we have these parentheses around these two complex numbers, which is fine. And since we're subtracting, what we need to do before we remove those parentheses is to distribute this negative in, right? Because we're subtracting the entire quantity. So we're actually subtracting 3 and we are subtracting the 2I as a quantity. So when we move those parentheses, we have to apply that subtraction to both terms inside the parentheses. So what we're really going to get is 2 plus I minus 3 minus 2I, like that, okay? And then once we have distributed that negative, we want to make sure that we tend to this first thing, which is where we combine like terms. So the 2 and the negative 3 can be combined, right? So this 2 and the negative 3, those are just regular numbers, right? So we can combine those and get negative 1. And then let me highlight the complex pieces here, right? So we have the I and the negative 2I. Those can be combined as well, right? So I and negative 2I are going to combine to give us a negative I. So 2 plus I minus 3 plus 2I subtracts to give us negative 1 minus I. Right? And I made sure I combine my like terms and distribute that negative. Okay. So let's talk about multiplying complex numbers and some of the things that you want to remember when you multiply complex numbers. First, use a box. Okay, so we've talked about multiplying things before using the box method with that lattice multiplication. Use a box. It's going to help you keep things in order and keep things organized as you do this, because when we multiply complex numbers like this, these are binomials, right? These are kind of hard to multiply straight out, so the box really helps out with that. All right, and the last thing that you want to make sure you tend to are the powers of I. Okay, so powers of I, because when we multiply, sometimes the power of a complex number can be increased, and when that happens, we need to make sure that we simplify using what we know about the powers of I. All right, so let's do the same example, right? But this time we're going to multiply, right? So I'm going to get rid of everything here, and we'll replace subtraction with multiplication like this, right? So we're really multiplying these two numbers now. All right, so let me show you how to use the box to do this. All right, so I'm going to draw my box. Don't worry, we're not factoring. Okay, not yet. And I'm going to chop this thing up, right? Do a 2 by 2. And the reason I'm doing a 2 by 2 box is because in each complex number I have two pieces, right? So I have a 2 and an I. So that way I can take 2 and the I and put it here like this along the side of my box. And then over here on the top, I'm going to do 3 and 2i, right? And everything's positive here, so we don't have to worry about any negatives. All right, and then I just go through and multiply just like we've done before in the past, right? So if I do 2 times 3, we'll get 6. And if I do 2 times 2i, we get 4i. And if I do 3 times I, we get 3i. And then for this last one, we're going to do 2i times I. And this is where we get a power of I, right? So 2i squared, okay? And then to finish this off, we would add the 4 boxes together. So we would get 6 plus 4i plus 3i plus 2i squared. And then you're going to combine any like terms that you can, right? So that would be the 4i and the 3i. So we get 6 plus 7i plus 2i squared. And then we're going to 10 to the powers of I, right? So we know from previous lessons that I squared is -1. So we've got 6 plus 7i plus 2 times -1. Okay? And then we can multiply that out. So we got 6 plus 7i minus 2, and then combine like terms one last time. 6 and -2 combine to give us a 4, so we get 4 plus 7i. And there's our final product after multiplying these two complex numbers. So 2 plus I times 3 plus 2i is 4 plus 7i. All right, so that's a quick example of multiplying complex numbers. And like I said, just don't forget, you know, these little things. These are the things that students tend to forget when they do these types of problems. All right, so let's give it a try. All right, so we're going to add and subtract. So we've got an add, we've got a subtract. Let's just do it real quick. All right, so when we have parentheses like this, before we can move parentheses, we have to check and see if there's anything to distribute. So when there's nothing in front of the parentheses, like these, we get to assume that these are ones, right? And if I distribute a 1, nothing changes here. So we can remove those parentheses and just say 3 plus I. And then we look at this one, right? So we have a positive 1. Again, that's the number that's being distributed. So 1 times 5 is just 5, and 1 times 2i is just 2i. So it's like we remove the parentheses without anything changing. Then we look for like terms to combine. Okay, so the 3 and the 5, those are regular numbers, so we can combine those. So that's going to be 8. And then we have I and 2i. So 1i plus 2i is 3i. And that's it. That's as good as that one's going to get. We cannot combine the 8 and the 3i. They're not like terms. And we have successfully added together everything that we can. Okay. So now we come over here. It's the same exact problem. Only difference is they have changed it to subtraction. So we apply that same principle, right? We have the ones out front of the parentheses here. We distribute a 1 into the first one. So we get 3 plus I. Nothing changed with that one. However, with this one, you've got -1 being distributed in, right? Because it's a minus. So -1 times 5 creates a -5, right? So that does change that value inside of the parentheses. And the same thing here, -1 times 2i makes a -2i. So you can see the difference between the two problems when we switch from addition to subtraction, and it's this distribution of the -1, what I call distributing the negative, that students always tend to forget. All right, so now I'm going to go here. There's my like terms, right? 3 and -5, and when we add 3 and -5 together, we get a -2, and then we have I minus 2i, which is -i. There's our final sum, right? So -2 minus I is our final answer for that one. Okay, so let's try multiplying. Let's try some multiplying and adding side by side. Okay, and notice over here it says special cases for the conjugates, right? And this word conjugate, all right? So when they talk about conjugates, what they mean is you're going to have one complex number and its opposite, right? So you'll notice here we have 2 plus I. Its conjugate is 2 minus I. So all they did was they changed the operation between the real part and the imaginary part, all right? So for instance, if I had 4 plus 2i, its conjugate would be 4 minus 2i. So when we talk about conjugate, the only thing that changes is the operation in between the real and the imaginary parts of the number. Okay, so doesn't seem like that's important, but you're going to see some things happen here because conjugates do some pretty cool things when you add and subtract them. So let's see what happens here, right? So we have 2 plus I, right? Nothing's going to change if I distribute a 1. So we're going to say 2 plus I. And then over here, same thing. We're going to get plus 2 minus I. And then we're going to combine like terms. 2 and 2 become 4. And then we have positive I and negative I. And when I add those together, we get 0. So we have 4 plus 0, which is 4. So I added two complex numbers together and got a regular number, right? A real number. So that's one of the cool things with conjugates is that conjugates essentially provide us a path from the complex number back to a real number, okay? Well, let's see what happens when we multiply. All right, so remember this is multiplication, so this is where we want to use a box. Okay, so I'm going to set up a box, 2 by 2 again, right? Because each of my complex numbers here has two pieces. Right, so we have 2 plus I, and then 2 minus I. Right, let's put it along the sides like that. Now we're going to multiply. 2 times 2 is 4. 2 times I is 2I. 2 times negative I is negative 2I. And negative I times I is negative I squared. Okay? So there's our four pieces. We just have to add them together, and I'll do that over here. So I got 4 plus 2I minus 2I minus I squared. Combine like terms. Okay, so remember our like terms right here, right? So I have two things with an I in it. I and I squared are not the same thing, all right? Don't try and combine those. So we're going to say 4, and then 2I minus 2I is just 0, so we'd say 4 plus 0 minus I squared. All right, well, 4 plus 0 is just 4, so we got 4 minus I squared. All right, so this is where we got to make sure we attend to the powers of I, and remember that I squared is equal to negative 1. We talked about that in a previous lesson, so we've got 4 minus, and then I squared is negative 1. So we have 4 minus a negative 1. And when you subtract a negative, that's the same thing as adding, so this just becomes 5. And we kind of notice there again, we multiplied conjugates this time, and we still got to a regular number. That's the cool property about conjugates, is if you add or multiply two conjugate complex numbers, you're going to end up with a regular real number. Okay, so there you go. Another couple of examples of adding and multiplying and looking at that special case of the conjugate. All right, those conjugates will pop up again in later lessons, so don't forget about those. But let's move on to our next goal here. We talked about wanting to be able to write the equation of a polynomial if we knew its roots, and we want to make sure specifically that we get into standard form. All right, so remember, standard form kind of looks like this, where we have ax squared plus bx plus c, right? So no parentheses, everything's being added or subtracted. So this is how we want our answer to look when we are done. All right, so we're gonna do a simple polynomial here, and this polynomial has the roots x equals 2 and x equals 6, so only two roots. And we know that we can write an equation in factored form very easily. All right, we've done this before, right? So if I have a root of x equals 2, then I can have a factor of x minus 2, right? And if I have a root of x equals 6, then I'm going to have a factor of x minus 6. And there we technically have the equation of our polynomial. It's just not in standard form. It doesn't look like this. All right, so to take this thing and put it into standard form, we need to multiply these two factors out. Okay, so I'm going to grab a box. All right, so just like we did with the complex numbers, we can use our box to help us with multiplying these things. All right, so again, a 2 by 2 box because each of my factors has two things, right? An x minus 2 and then an x and a minus 6. So we've got x minus 2 and x minus 6. And I just put it across the top and the side. And it doesn't matter if you put the x minus 6 over here instead, you're going to end up with the same thing. All right, so let's multiply this out. So we got x times x, that's x squared. X times negative 6 is negative 6x. And then x times negative 2 is negative 2x. And then negative 6 times negative 2 is a positive 12. All right, don't let those negatives trip you up. A negative times a negative is a positive. Okay, so here we go. So I've got x squared minus 6x minus 2x plus 12. All right, so we're starting to look like this thing now, right? So all I got to do is combine like terms, right? And when we multiply out polynomials like this, like terms are usually right here in the middle. So we're looking for something that has the same variable raised to the same power. So that would be these two guys here. They both have an x. Both of those x's are raised to the first power. Okay, so when I combine those, I get x squared minus 8x plus 12. And there we go. There is our polynomial in standard form. Looks just like this. All right, so pretty easy, right? Roots to factored form to standard form. Let's give it a try. This time with complex roots. Okay, so we got a polynomial. We have our roots. Okay, so 2i and negative 2i. So these are complex, not a big deal. Remember, our goal is to get to something that looks like this, right? Because we want to be in standard form. But we can start off with something that looks like this, right? Where we have our two factors, right? Because we have two roots, so we should have two factors. And we can write a factored form much easier than we can a standard form. So if we can get into factored form first, then we can use our box to get into that standard form. Now remember how the relationship between factors and roots work, right? It's always the opposite. So if I have a positive 2i as a root, then I'm going to have negative 2i in my factor, right? So x minus 2i is the factor that corresponds to positive 2i. And then I do the same thing for negative 2i. So if I have a root of negative 2i, I'm going to have an x plus 2i in my second factor. So there's the factored form of our polynomial. Now all we have to do is use our box. Here's my box. It's going to be a 2 by 2, right? 1, 2. So I have x minus 2i and x plus 2i. All right, so let's multiply. So x times x is x squared. And you'll notice like nothing is really different. The process that I'm using, the technique that I'm using is the same as the previous problem. It's just we have some i's going on now. All right, so when I do x times negative 2i, this is a little bit new. And we just multiply it all out. We'll have negative 2ix. Okay, you could do 2xi if you want. It doesn't matter what order it's in. It's just you're multiplying those three things. Okay. We're going to do the same thing down here. We've got x times 2i, so this is going to be 2ix, just a positive version of it. And then we're going to multiply our two complex numbers to get the bottom right-hand box. So 2i times negative 2i is negative 4i squared. And that's another mistake that students tend to miss right there, is when you multiply those two i's together, you get that I squared, okay? Now we add our four boxes. So we've got x squared minus 2ix plus 2ix minus 4i squared. And this thing does not look pretty. It kind of looks like this, right? If I say, okay, well, this is an equivalent equation to this one, but it doesn't look like this one yet. Well, let's see what happens, right? And notice that these two are conjugates. So we know that when we multiply conjugate complex numbers, we should end up with a regular number. All right, so let's see what happens here. So like terms have the same variable raised to the same power. So notice this one and this one both have an ix in it. So I can combine those. So I'm going to. So we've got y equals x squared, negative 2ix, positive 2ix. All right, so they're opposites of each other, and when I add them, I'm going to get 0. All right, so I have x squared plus 0. These guys combine to 0 minus 4i squared. Okay, so a little bit more simplifying there. I really don't need the 0. X squared plus 0 is just x squared. So I have x squared minus 4i squared. Well, recall from a previous lesson that I squared is negative 1. So I'm going to replace that I squared with a negative 1. So I'm going to say y equals x squared minus 4 times negative 1. And we keep on going here. Y equals, we're getting closer to something that looks like this. All right, so y equals, and then negative 4 times negative 1 is a positive 4, so we would say x squared plus 4. And there we go. That's our equation in standard form. Okay. All right, guys. That's it for today's lesson. If you have any questions, make sure you ask in the Zoom chat. Make sure you give those practice problems a try. I'd love to help you out if you get stuck on those. Good luck.